Assalamu alaikum, my dear student. Today our topic is Fermat Principle. Fermat Principle. Fermat Principle, also known as Principle of Least Times. Also known as Principle of Least Times. Fermat Principle is named after a French mathematician Pierre de Fermat in 1662. Okay, now we understand definitions. State that the path taken between 2 points by a ray of light is the path that can be traversed in the least times. Now we better understand with respect to figures. State that the path taken between 2 points. Path taken, this is path taken between 2 points P and O by a ray of light. By a ray of light is the path that can be traversed in the least times. This path taken in the least times. For least times we count, for least times, minimum times. That is the reason this principle is sometimes taken as the definition of ray of light. Definition of ray of light. Okay, we proves law of reflections by Fermat principle. By Fermat principle we prove the law of reflection. Law of reflection, we know that what is the law of reflections. What is the law of reflections? We also know that the law of reflections, reflection of light, means when light traveling in a certain medium fall on the surface of another medium, a part of it turns back in the same medium. This is called reflection of light. That is the reason this is the incident ray fall on a point of incident, then reflected back from O to Q. This is called reflection of light. And also we know that the angle of incident is equal to the angle of reflections. We proves the angle of incident equal to the angle of reflections. That is point we prove in law of reflections. First we know that we count least times. Okay, P is a incident point and Q is a reflected. Okay, the incident point fall on O and O then reflect from O to Q, incident and reflected. And H is a perpendicular from A to O, and H2 is also perpendicular from B to Q. The total distance is D. The distance from O to A to O is X and O to B is dx. Mean total distance D and neglected D, neglected X from D, then is equal to D minus X. We proved least times. We know that velocity is equal to distance over times, but we count times. Time is equal to distance over velocity. Okay, first incident ray, incident point P to O. This is a point P to O is a distance and divided by velocity, and also we added in reflected ray O to Q. This is a reflected ray also included in time because we count least times. We count principle of least times. Also included reflected ray O to Q. This is also we include. This is a hypotenuse. We also know that hypotenuse is equal to square root of h1 square plus x squares. This is hypotenuse. And we also know that hypotenuse of point O to Q is equal to x2 square plus d minus x squares. Okay, we use this value here. Okay, after putting the value, we obtain t is equal to square root h1 square plus x square over v, and plus also this square root h2 square plus d minus x, d minus x की whole power 2 over v, taking v common from both. Now we taking derivations. Differentiation with respect to x means changing times with respect to x. Okay, derivation of t with respect to x and includes here's and here's derivatives. And how we take these derivatives, then you easily understand. After this we take derivative of square root x. We know that the value of square root 1 over x, this is. And after derivating we take value first, then neglect the minus 1 from value, and then we take the derivative of point. Okay, the derivative of x with respect to x is 1, and taking commons from here 2, and to multiply 1 minus 2 and 2, 1 over 2 x, 1 minus 2 is equal to minus 1 over 2, and we also know that we write in this way. Okay, clear? That is the same process we use here. Derivatives first, we know that the square root value 1 or 2, then also in short steps 1 over 2 minus 1, but we also obtains minus 1 over 2, and then derivative of this, and same process, square root value first, then the neglect minus 1 from this value, we obtains minus 1 over 2, then the derivative of this. And how we solve this, we also solve in another page, we understand from this. Okay, clear? That is here 1 over x, this is also, and we also take derivative of this. Check here, 1 over h1 squares, h1 square 2 is a constant, the derivative of constant is 0, that is the reason we take 0, and the then derivative of x square is equal to 2x, and also here this is same process, and here's h2 the derivative, h2 is also constant, the derivative of this is 0, this is 0 also here, and also again this derivatives of this first powers, then neglected this, and we obtain this. Okay, and here's 1 over 2 and 2x, and is a minus 1 over 2, then divide and write in square root, and also this is write 2d minus x minus and 2 and 2, and also minus 1 over 2, and write in divide from this and write in square root, and also we cancel, same cancel. Okay, and we obtain this value minus, and minus multiply plus, and also obtain minus. Okay, clear? And here's this is same, we give names 1 this equation. Okay, according to Fermat principle, d over dx is equal to 0. We know that sine theta 1 is equal to perpendicular over hypotenuse, and sine theta 2 perpendicular over hypotenuse. We take from, we better understand from figures. This is, we take sine theta 1, not this, this is always on the front of angles is perpendiculars, and this side is a here's this side is perpendiculars, and this side is hypotenuse. Clear? And this side is perpendicular, and this side is hypotenuse, for because always perpendicular on the front of angle, that is the reason. Okay, hypotenuse we know that h1 squares over x square. Okay, that is the reason. X squared, this is a perpendicular and this is a hypotenuse. We also understand how we obtain hypotenuse in from figures, and that is also sin theta 2. Sin theta 2, this is here sin theta 2, and hypotenuse, this we know that OQ, hypotenuse h squared and d minus x squared. Okay, understand? That is the reason we use this value here, same then use here. We obtain d over dx is equal to 1 over v within bracket sin theta 1 minus sin theta 2. We know that from Fermat principle d over dt over dx is equal to 0. That is, we write in 0. Okay, clear? Now we also explains here. Okay, the v is right side is equal to 0. Then we obtains sin theta 1 minus sin theta 2 is equal to 0, and from the other side sin theta 1 in sin theta 2 is equal to sin theta 1 is equal to sin theta 2. This cancel is equal to sin theta 2. That is, we proves this side angle of incident is equal to angle of reflections. This is our final observations. The law of reflection also prove the angle of incident is equal to the angle of reflections. Fermat principle prove the law of reflections. Okay, clear? Any confusion, comment you are in comment box. Okay, thanks for watching.